Well, hey, how's it going, Farron? Thank you so much for making some time to hang out and chat for a little bit. My name is John Hammond. I'm super excited to be able to meet all of you over here at HALBORN. This is the first time I finally get to meet you in person, so I'm very excited for us to chat. If you don't mind, if we can kind of, set the stage here, do you mind introducing yourself, what you're up to, what you're doing at HALBORN, what you're focusing on, and then we'll dive into some cool conversation.
Sure. First of all, just a pleasure to meet you in person. It was, since I was young, I watch your videos and I started learning a lot of security stuff from your videos, and I really appreciate all of the effort you put on your channel.
Thanks.
So yeah, let me introduce myself. So I'm Farron. I'm actually the principal security engineer at HALBORN. I basically work on Ethereum stuff and also some internal tools to help all the newcomers that are joining HALBORN to be more productive and more focused on their work. And so yeah, basically mostly Ethereum-based projects. I do security audits and also some web pen testing as well, but mostly Web3 Ethereum projects.
Well, hey, I'm super excited because I think this will be probably the most, I think there's a lot to unpack, right, with Ethereum,
Yeah,
absolutely, and a lot of people are going to be super duper interested in, hey, what is this whole thing, to get all the pieces of the puzzle. If you don't mind, again, just to kind of get the ball rolling, how would you define or put in the picture, the big picture of Web3 and blockchain technology, what is Ethereum, in your own words?
So basically Ethereum, we can say it's like a global computer. So
Okay.
it's a decentralized, let's call it this way. We later can discuss about the decentralization part, but it will be like a decentralized computer where there are a P2P network where all the nodes agree on the results of these computations. It's a Turing complete system, and basically everyone can compile stuff and run it on this decentralized computer. Ethereum was the first chain to get out there. That allows smart contracts in a Turing complete way, and it's pretty cool, I will say.
That's awesome. How does Ethereum, I guess, look to you on the day-to-day operations? Like, hey, when you're firing it up on your computer screen, right, being an engineer and interacting with this thing, is that in Solidity? Is that in Rust? Is that in Python? Is there what sort of languages, or how do you interact with it and wrap yourself around it?
Yeah, so Ethereum at the end is just a VM. So it's like a sandbox VM where everything is executed there. There are so many different languages that can be compiled on EVM code, but at the end it's the same. So in this case, there is Solidity, which is the standard language that we are using on Ethereum. And there is also Viper, which is Python based. And for Ethereum 2, which is coming, I guess, on the following months, we have WebAssembly. So you are allowed to use whatever programming language you want, as far as it compiles to WebAssembly.
Wow.
Yeah. Then that gets translated to EVM code, and it will execute on Ethereum, which is amazing. So we used to do mostly Solidity-based audits on HALBORN.
Cool. So, forgive me, right? I'm very naive in this whole world, right? But EVM and the bytecode, as you mentioned, that runs it, you sprinkled in there something EVM2, is that right? Or what the heck is that? That's completely new to me.
Actually, it's not EVM2.
Okay.
It will be almost the same. It's Ethereum 2.0,
Gotcha.
which is only on the validation side. Everything will be kept the same, probably, and it's only on top of that. That's it.
Wow. Does that change the outlet, I guess, from your perspective of security, of audits, of technology? And maybe that's worthwhile kind of pouring into that conversation of, in my mind, Ethereum has always been like, hey, it's a well-established, known thing. It's up there with the Bitcoin. It's up there with the origin story here. Where do vulnerabilities come in? How does hacks and incidents and all this stuff still make headlines when they come about?
It's always the same. At the end, everything is public on Ethereum. So there are, for example, Etherscan, which is the main source of checking your source code of contracts. Since everything is public there, anyone can look at the code, find issues that probably were skipped during audits, and yeah, that's why all the big hacks just happen, basically. Something that was forgotten, or probably some stuff that was not checked during audits. Most of the major hacks that happened recently, they were not audited, actually, which is kind of interesting, yeah. There's a really good page called rect.news, where you can see all the recent hacks, mostly on Ethereum, and all of them, almost all of the top ones, haven't been audited.
Wow. Okay.
So yeah.
Guess that's a good arrow in pointing direction. Hey, you should go for an audit, right?
Of course, we always recommend to have audit, of course, with us if it's possible, but at least have 3 different audits, not just one company. So more people looking at your code, it increases the chance of finding a really critical issue.
I know there was some conversation we were kind of bumping around on earlier. Was it like, sure, you could run some automated scanner, quote unquote, but that doesn't do the full justice, right? I know, hey, I'm of the same opinion, like you have to have human eyeballs on it. You have to look, you have to go through the manual effort. Is there room for improvement? And will we ever get to a point and replace, are we getting away from you human beings being able to do this audit? I don't know.
I don't think so. Security has been for a long time already on Web 2. Did we find a way to actually do some automation on everything? Almost no. It's like kind of impossible. We always need like humans looking at the code. And in this space, on Web 2, it was different. Because, for example, when you find an issue, it doesn't imply direct financial impact. But on Ethereum, it does. If you find like critical or something that can cause issues on the code, usually it translates to financial losses directly, you know?
Yeah. I know, hey, like literally you forget a semicolon or you don't have the rest of the comparison operator, that's $2 million down the drain.
Yeah, for example, having like a greater sign equal than you're forgetting the equal sign, so
absolutely.
That can cause a lot of issues.
Are there any that stick out in your mind as like, oh wow, that was a crazy big story-breaking hack? Or I know, hey, you're more of the technical mind. What can I ask if you're able to dive into any of the details or anything remotely close? It's like what makes the big difference? What's one of the big ones that sets off alarm bells in your head or your eyes go crazy when you see something like that?
There are actually a lot of issues I have found that are quite critical, and mostly all of them are logical, I will say. It involves all the business logic on that they are just basically coding on the smart contract. And when you start looking deep under code, if you use like an automated scanner, you will not find, of course, those kind of issues. You need to understand the code and put your effort there, try to learn what they are trying to do and what they are actually doing. If you are able to dissect all of those aspects, you will find really some critical issues. For example, just an opinion, a recent project I did audit that was already published on mainnet on Ethereum, and we later got the audit. We did check the source code, and we found 2 criticals.
Wow.
And that code was already published because it was audited by other companies, and they were expecting to be like a solid code, but we found some issues on there.
Wow.
Yeah.
I think it's crazy because, as you mentioned, hey, it was audited by others, but they didn't find that because they maybe did however much surface level digging. Like we say, oh, you just run a cheesy Nessus scan or something in the Web 2 or traditional sense, right? It's very. I'm happy to hear, when we're going above and beyond and seeing more of those issues come to light. That's crazy.
That's what happened a lot. It happens a lot actually. That's why we recommend to have more than one audit.
Good call.
Because the code does change as well. I mean, when you are improving stuff in the code, it does change. And probably just adding like a new line, it breaks everything else. And you have to be aware of that. For example, like 2 weeks ago, there was like a hugest hack on Ethereum.
Oh, wow.
It was the running hack. It involves like 6 million losses of funds.
Wow. Goodness.
And it was not Web3 related, actually. It was the losses of the private keys of the validator nodes, actually. So again, does it mean that all the issues are only Web3 related? No, we're still finding some issues as well on the Web 2 aspect or the key management system that clients do use.
Can I ask, are those seemingly more common, or is there a majority? And oops, well, we're still ironing out the quote unquote Web 2 kinks.
Probably, I will say, yeah.
Okay.
Yeah,
that's interesting.
There's still a lot of issues on the Web 2. So, because at the end, Web3 itself is complicated from a user perspective. So you need a front end or some way to interact with the contracts. So mostly all the issues come from this connection, because they assume that only users will be interacting through the front end. But sometimes you can go directly to the contract if you know how to do that. and just call some random functions that were not exposed on the front end, you know?
Oh, goodness.
Like
Yeah.
removing fonts or whatever. Some stuff that the devs did miss there.
Wow. That's wild.
Yeah, happens a lot.
Can I ask, is Ethereum, right? Because again, I know obviously there are new kids on the block, whether it's Solana or Near or Cosm or any of the other things that pop up. Do you feel like, or are you losing what Ethereum once was? Is it losing its prominence?
I think I got you. Probably, kind of, I will say.
Okay.
Let's talk about, for example, the decentralized aspect. We talk about all blockchains as being decentralized, but what is really decentralized? Because actually, at the end, all the nodes that are running Ethereum are hosted on a cloud service. Let's say, for example, Google Cloud, Amazon WS. So do we truly call that decentralized? Even though they are managed by different people, but at the end, all of them are running on the same infrastructure.
Right.
So that's what happens for probably 90% of the nodes on Ethereum. So the original aspect of Ethereum was to be decentralized. And I don't think that this aspect, for example, is achieved.
Huh. Because when I hear decentralized, I always think, or I wonder, like, okay, you mean some engine, something running on every user's computer, like their personal device, right? But as you mentioned, hey, if it's all on AWS, if it's all on GCP, that's clearly not their own personal device.
Of course.
Huh.
And let's talk, for example, about scalability as well on Ethereum. Right now, Ethereum is able to handle 30 transactions per second. That's not a lot. If you want to scale this out in a global basis, you need to handle thousands of transactions per second. And that's what Ethereum 2 is trying to do as well. So the idea of Ethereum 2 is to have the nodes even on your phone, your cell phone. You can host a node and be part of that network. So you are able to handle like 100,000 transactions per second. That's the idea of Ethereum 2.
Nice. Will that be moving away from AWS or GCP hosted stuff and try to encourage more to get on their phone?
Yeah, that will be the idea.
Cool.
But for that, we need to transition from proof of work to something else, because proof of work is very energy consuming. And you cannot use that on a mobile phone, of course.
Gotcha. So does that make the switch to proof of stake?
Yeah.
Is that right?
Yeah,
Okay.
this is right. That's the idea.
Goodness. Some things to track here and there.
And for example, what about privacy on Ethereum? Because at the end, everybody talks, this is like kind of private network where you can send funds and nobody can track you. But at the end, everything can be tracked on Ethereum. You just follow transactions inputs and outputs, and you can get from where the funds were to where the funds are. That's it.
I was just chatting with someone else that was explaining, hey, when you can do something like on Etherscan or with some blockchain explorer, if you can attach a memo or some messaging to have like, some HTML injection to do, cross-site scripting, I guess,
example.
Web 2 stuff, right? Still, okay, there's a vulnerability, quote unquote, vulnerability there, or some potential weakness that could be exploited or taken advantage of. Is that what you tend to still see, or is it a completely different ballgame?
So I will say that this is mostly done on the Web 2 side. On the Web 3, there is no like injection or whatever, you know. Everything is stored on a level DV system, so it's like a tree.
Okay.
So basically, when you are storing stuff, you are storing it on a tree. You are not storing it on a database, let's say. So it's kind of like, a balance. Those typical issues like cross-site scripting, injections, and all of that, they are still present on Web 2 interface to the Web 3, but not on the Web 3 itself, at least on Ethereum.
Does Ethereum, I guess, make for a whole lot of opportunity in that whole NFT space, right? I figured that's another can of worms to open up. I don't know if you think. Does that change the game? Is that a very different thing to audit or look through? Or can we go down that road at all?
Yeah, sure, of course. I actually don't really like NFTs at all.
Okay.
Because
strong stake.
Yeah, it is a strong stake. Because not because the technology is not good, but how the developers are actually implementing it. I will say, for example, OpenSea, I don't know if you are aware of it, which is like an NFT marketplace, so everyone can put their NFTs, just transfer, buy it, and so on. Just the collections, NFT collections, they used to quote, so for example, let's pick a client which is trying to develop a collection of NFTs. They will not take, usually they don't take the code from somebody else. They just do their own code. And sometimes they can come up with some really big issues as well. So let's imagine, for example, recently I just did an audit on an NFT contract, and they were doing some random calculations to mint NFTs. So people could interact with the contract and say, yeah, I want an NFT. I want just to mine an NFT. And they were generating some random numbers and giving you an NFT, random NFT, okay? Just perfectly fine. The implementation was wrong, and you were able to change the way how the random number was generated.
Oh, wow.
And you were able to manipulate random number, so you could always get the best NFT of the collection. And that's something I have found a lot of times.
Was that just based off like, user input some way, somehow, seeding the random number generator?
Actually, no. Actually, block timestamp. Block timestamp and the sender of the contract. So all of those parameters can be manipulated. When developers tend to do stuff for Ethereum, they think about a transaction as being something that cannot be manipulated. So once it's sent to the block, it gets there as it was. But in reality, you can do a lot of stuff. Like, for example, sending your transaction first that is causing some state changes on Ethereum that will affect the following transactions.
That sounds sort of, and I might be completely oversimplifying this, but you're sort of manipulating time, right? And like the order of operations, is that fair to say?
Yeah, kind of, yes, sort of. So, on Ethereum, the blocks are generated based on some parameters, but at the end, it's the miner who picks the transactions and put it on the block.
Gotcha.
We trust the miners. That's what we think on Ethereum. We trust the miners. Are they decentralized? We saw that they are not decentralized, but anyway, we trust the miners. So if the miners want to, extract value or just do some weird stuff on Ethereum, they can just get transaction before another if they want, and that's it.
Wow.
It usually not happens like that because there is like a standard way of sorting the transactions, but it's possible.
Okay. I mean, hey, knowing it's possible is still enough for, some folks to try and weasel their way in.
So yeah, of course.
What are you up to nowadays, if that's all right? Is it sort of, hey, rinse and repeat one audit after the next, or are you doing some research and development, trying to figure out some new crazy cool offensive technique or hack or something? Can I ask? Is there any what are you up to?
Sure. I have been doing a lot of security, smart contracts audits, and I have seen a lot of issues. And probably I will say that all the issues can be categorized in the same way. So they are all always logical faults or ownership and access control faults. Probably all of them are like that. So we are on HALBORN, actually, I'm doing some research as well and developing some stuff. We came up with a really good solution that will be probably made public in the following weeks or probably months, where it tries to solve all of that. We have seen, for example, and we have replicated all the recent hacks that have happened on Ethereum.
Wow.
Using our tool, and they are protecting all of them, which is really amazing.
That's awesome.
Yeah. It is, indeed. And we are very happy with that tool. We are still developing it, and we already have talked with some clients, and it will be sent out on public in some months. That
is super exciting. I can't wait to hear about that and see it out in the wild, seeing what it's up to.
Yeah, it would be amazing.
I've been chatting with some other folks. I think, hey, there might even be some parallel, and I don't know if the cat's out of the bag on that one, but like an OWASP top 10, but more for Web3 blockchain vulnerabilities that you might tend to see. How it's found, how it's uncovered, how it can be fixed. Is that still something that might be in your wheelhouse, or is it just other cool stuff happening at HALBORN?
So there is the SWC, which is a register of let's say, the most typical vulnerabilities on Ethereum. And they tend to be nice, but sometimes outdated. Because this was made when Ethereum was starting out, and some of the issues that are presented there are not useful anymore, let's say. But there is not like a top 10 OWASP aspect on Ethereum, I wouldn't say.
If someone really wanted to get into this whole thing, if they wanted to learn blockchain security or Web3 or anything, or getting into Ethereum, it sounds like, hey, that might be the candidate, right? That Ethereum could be their vessel and venue into that. What should they do? Is that, I've heard things, the Ethernaut CTF, is that right? I don't know if,
Yep.
Or what other tools or resources, or how can someone really start to dive in on this thing?
Yeah, sure.
How can you become a principal engineer at HALBORN?
Yeah, of course. I will not throw people to reading, for example, the yellow paper, because this is not feasible for everyone.
Yeah.
You need like a master's degree to understand that. So, so I will say, yeah, basically understand at least how EVM works, how Ethereum works, how blocks are put in together, how a transaction is made, all of that underlaying, because it will help you later on, just for your knowledge. And then start just coding, I will say. This is the best part. Not if you want to start doing some security, you can do that. But I believe that knowing how to code on Solidity, on Ethereum, it makes more sense for you to start learning about the protocol.
Cool.
Yeah.
I'm excited to hear that, because it always seems like the best answer is like, all right, well, I pop open and play with Solidity.
That's the best option, I believe. Yeah.
I hope we can probably maybe put some cool videos or content together diving into that. I think that would be awesome.
I would love to do that.
Tutorial series or something. Make it real.
Sure. Just some Solidity coding as well. And then after that, when you are able to write your own code, try to understand if you could possibly break it.
Yeah.
You know,
Ooh.
Is this a public function? Can I call it? Can anyone call it? Can it cause issues? Just do something like that. Read code. This is the only way to really get into it.
Sweet.
Yeah.
Well, hey, thank you so much, Farron. What do you think? Is there more? Are there more stones left unturned? Anything else we should chat about? Any other cool conversations you want to drive down?
I think we could spend all the entire day here chatting about a lot of stuff. But
Thank you. This has been awesome. I, for one, had not learned a whole lot. I did not know much about Ethereum beforehand. So, I mean, this has been awesome to get a slice of life for what you're up to, what audits are looking like at HALBORN, and more on the way. So, excited to have our next conversation. Thanks so much, my friend.
thank you. It was a pleasure, as I said, Naomi.